In talking about Faraday's laws, we first need to look at his experimental setup. So, looking at this setup, when the battery right here is disconnected, we have no electric current flowing through the wire. Hence, there is no magnetic flux induced within the iron, this magnetic core right here. The iron is like a highway for magnetic fields. They flow very easily through magnetic material, so the purpose of the core is to create a path for the magnetic flux to flow. When the switch is closed, so we do that, the electric current will flow within the wire attached to the battery. When this current flows, it has an associated magnetic field or magnetic flux with it. When the wire wraps around the left side of the magnetic core, so the left side of the magnetic core, right here, a magnetic field is induced within the core. This flux travels around the core, so the magnetic flux produced by the wired coil on the left exists within the wired coil on the right, which is here, which is connected to the ammeter. Now a funny thing happens, which Faraday observed. When he closed the switch, the current would begin flowing and the ammeter would spike one way, let's say to the positive 10 amps, but this was very brief and the current on the right coil would go to 0. When the switch was open, the measured current would spike to the other side, let's say the negative 10 amps, and then the measured current on the right side would again be 0. Faraday figured out what was happening. When the switch was initially changed from open to closed, the magnetic flux within the magnetic core increased from 0 to some max number, which was a constant value versus time. When the flux was increasing, there existed an induced current on the opposite side. Similarly, when the switch was open, the magnetic flux in the core would decrease from its constant value back to 0. Hence, a decreasing flux within the core induced an opposite current on the right side. Faraday figured out that a changing magnetic flux within a circuit or closed loop of wire produced an induced EMF or voltage within the circuit. He wrote this as this equation. The equation says that the induced voltage, the EMF, in a circuit is the opposite of the time rate change of the magnetic flux. Now, this equation also has a negative sign. This negative sign comes from Lenz. So this equation is also known as Lenz's law. Lenz was the guy who figured out the minus sign. We know that an electric current gives rise to a magnetic field, but thanks to Faraday, we also know that a magnetic field within a loop gives rise to an electric current.